we will continue with the masking programs that we have been doing in the last session. So, masking, we have masked the diagonal, if you remember. We have masked the values below the diagonal. We have masked the values above the diagonal. Now, we will be masking few particular numbers within the matrix. Few numbers depending on whichever numbers the user wants. Now, masking means I am talking about the shielding. I told it shielding in the previous lesson. However, we may also call it masking. Now, how to shield particular numbers or mask particular numbers within the array? Let me try to understand this with an example. Say the array is 9, 8, 7, 6. I am talking about the matrix. 6, 4, 3, 9, 7, 3, 8, 1. So, this is the matrix for you. 3 rows, 4 columns. Now, with this, user will be providing a shielding matrix, or we may call it a masking matrix, saying whichever number he wants to mask. Say he wants to mask this 9. He wants to mask this 6. He wants to mask this 4. He wants to mask this 8 and 1. That is particular numbers user wants to convert to 0. So, user will be providing a masking or a shielding matrix like this. Say 0, 1, 1, 0. Followed by 1, 1, 1, 0. Followed by 1, 0, 0, 1. Check out, this is the masking matrix user has given. What does that mean? The masking matrix will consist of only zeros and ones, no other number. It will consist of only zeros and ones. A 0 in this position will mean that the original matrix in this position will be 0. That is, this 9 will be masked. Similarly, 1 and 1 will mean it will not be shielded or masked. 8 and 7 should remain as it is. 6 is this, so this 6 will be masked to 0. Similarly, over here 1, 1, 1, I mean this 3 will not be masked. That is 6, 4, 3 corresponding positions in the original matrix not to be masked. Instead, 9 to be masked definitely, because there is a 0 in the corresponding position of the masking matrix. You check this 2 position in the third row or the 2th row, I can say in programming terms, 0, 0, that means this 2 position has to be masked. That is, in our example, 3 and 8 has to be masked, has to be converted to 0. So, after the masking matrix is inputted and the original matrix is inputted, what should be your output of the program? See, the output of the program should be 0, 8, 7, 0. Check out why, 9, 8, 7, 6. But the 9 and 6 position, corresponding position of the masking matrix has been shown 0. So, the corresponding positions will have to be converted to 0. So, 0, 8, 7, 0. Now, 6, 4, 3, 9 to be masked. So, 6, 4, 3, 0. So, this 9 has to be masked, has to be converted to 0. 7, 3, 8, 1. The corresponding masking matrix shows 1, 0, 0, 1. So, 7, 0, 0, 1. Why 1? Because this is 1, but this position was 1, so it remains 1, 7, 0, 0, 1. So, this has to be your output. So, you remember, you understand over here that I will need one more matrix, one more 2D matrix over here. What is that matrix? Can I call that matrix mask matrix? It's a 2D array also. So, that matrix, let me call it mask NN. Mask NN. Mask NN means that this matrix is called mask. Size I want to have it same as that of A. So, it does not mean that there has to be n rows and n columns, but maximum n rows and maximum n columns, where n has been hash defined as 100. So, I will continue with the normal thing, enter the number of rows and columns, which you remember we scanned in m and n. Then I ask for the individual numbers from the user, enter the values of the matrix row wise. So, for I equal to 0, I less than m, I plus plus. enter the percent D values in the percent Dth row n and I. So I scan individual values of Aij. I varies from 0 to m and j varies from 0 to n because the number of rows and number of columns are entirely scanned for. So this entire thing has been scanned by the user, scanned by the program. Now what? Now I will have to go through all the elements of the array again. For I equal to 0, I less than m I plus plus. Similarly, within this, for j equal to 0, j less than n j plus plus, what do I need to do? For each number, that is, I am going through each and every element. So let me write it over here. Say this was 9876 6439 7381. Let me write another array over here. I do not care about what was written. Say 6 4 8 2 followed by 7 6 5 9 followed by 2 7 5 3. Now the masking matrix may be 1 0 0 1 followed by 0 0 1 0 followed by 1 1 1 0. This is the masking matrix. So what does this mean? This means in every case, see what I need to do. I am going through all the elements of the array. For I equal to 0, I less than m, I plus plus. I am going through all the rows. In each individual row, for j equal to 0, j less than n, j plus plus, I am going through all the elements of the column. All the columns, that is all the elements of each individual row. Here I need to check if Aij is equal to 0, is not it so? See what I mean to say. If a particular number, if Aij, not Aij, sorry, mask Ij, if mask Ij is equal to 0, why am I saying that? For each number that I am going through all the elements of this array. Now if mask Ij, corresponding position of the mask matrix is 0, then I need to do something. What do I need to do? Corresponding position of the A array should be converted to 0. Please check. If the mask matrix corresponding position Ij is 0, then the corresponding position of the A matrix will have to be converted to 0. So this much should be your program. This much should be able to convert the program or mask the corresponding elements to 0. I have not talked about those positions which are 1, because if in the mask matrix the corresponding positions are 1, then I really do not need to change that position of the A array. It remains as it is. So this much should be your program. So I can say I get rid of this part now. I get rid of this part. What I will do, I will print this array once before the masking and I will print it once after the masking. So I will print it once over here and I will print it once over here to see the differences. So for printing that, I just copy this part to make it easy. I don't need to write the whole thing, only the scan things I will be converting to print. So I have just copied this part. What do I need to do? See what? For I equal to 0, I less than m, I plus plus. So here I can write printf the array you entered, printf the original array. The original array is, what is the original? Original not array, let me call it matrix. The original matrix is /n over here. So this one. Original matrix is this. So I am printing the original matrix. For I equal to 0, I less than m, I plus plus. This part I do not need. Only I need to print the matrix. So for j equal to 0, j less than n, j plus plus, not scanf, but printf. %d, not ampersand aij, but only aij. So this much is printed. But remember, outside the inner for loop, I need to put a /n. See what? printf/n, because every row being printed, after that /n, and then you continue. So this is the original matrix. Now I need to print the matrix again after the shielding or the masking. After the masking, I need to print the array again. And printing the array, same array again, means it's the same piece of code. So let me copy this and do the changes. I copy this part of the code and print it over here. See, I print this thing over here, paste this thing over here. Now the necessary changes. What are the necessary changes? Printf, the matrix after masking is, for I equal to 0, I less than a, I plus plus, for j equal to 0, j less than n, j plus plus, printf %dij, printf/n. One thing, if you print it like this, the array will not look good, matrix will not look good. 2 spaces after each element being printed. Similarly over here, 2 spaces after each element being printed. So this part should be, this should be your program. If I run it, this should run fine. I have declared the mask array. Yes, I have declared it. So let me run this program now after I comment out this portion of where I explained the purpose of the program. So this part I commented out. Let me run this program now. Alt-R, enter. Enter the number of rows and columns. I keep it 3 and 4, easy to understand. 4 values in the 0th row, 2, 5, 7, 3, followed by 3, 9, 7, 6, followed by 4, 8, 2, 3. So see, now it will want the, oh sorry, I made a mistake. I did not want the masking matrix itself. The masking matrix, how do I know the masking matrix? The masking matrix itself I did not scan from the user. I need to scan the matrix, masking matrix again from the user. That part I forget. So let me just want the masking matrix. This part I should copy and paste, asking for the masking matrix. Here enter the values of the matrix row wise. Here I should write enter the values of the masking matrix. Once the original matrix has been scanned, here I should want the masking matrix from the user. But remember, the masking matrix should be containing only 1 0. So please write that 1/0. Masking matrix row wise. Looking at this, the user will understand. For the masking matrix, you will have to enter only 1 and 0. So same program, same thing. Enter the %d values and %d rows. Here also you please write 1 0. You cannot enter anything apart from 1 0. So now I scan it, but I don't scan aij. Instead I scan mask ij. So the masking matrix has been scanned from the user. Only then I can print the original matrix, then mask the corresponding values, and then print the matrix after masking. Let me run it now. So number of rows 3, number of columns 4. So 2, 9, 8, 4, 4, 5, 6, 7. So A 2, 6, 9, 3. So enter the values of the this array has been printed. Now enter the values of the masking matrix 1 0 row wise. So enter the values of the 0th row. 1 0 0 1 1 1 0 0 0 sorry 1 0 0 0. Now see, original matrix is 2984 4567 2693. Now 1001 is the first row of the masking matrix. So 2984 converted to 2004. 4567 1100 was the 1th row. So 4567 converted to 4500. Now 2693, the corresponding row of the masking matrix was 1000. So 2693 converted to 2000. I think you understand it. This program, you can run this program again, you can go through the program again and check how it is doing. I will continue from here with another thing. I will say now, I will just mask an entire, I will continue with the masking thing, but I will mask the entire row. What I mean to say is over here, I get rid of this part, I get rid of this part, I get rid of this part. Now, user says that I will have one array also again, but an array equal to the number of rows. The masking matrix will be equal, will be a 1D array consisting of the number of elements equal to the number of rows. How many rows are there? 3 rows in the original matrix. There are 3 rows in the original matrix. So I will now have a 1D array. The masking matrix will be a 1D array consisting of 1, 0, 0, 1, 0, 1, 1, 1 and zeros. Now what I mean to say is, this means which row you need to mask. Now I will be masking a row as a whole. I think I can explain you. In the past program, I was looking for masking particular elements. Now I am looking for masking particular rows. So 101 means why 3 numbers? Because there are 3 rows. So I will only indicate by the masking matrix which row I want to mask. So 101 means only this middle row I need to mask. This is 1. This indicates the 0th row. 0th row not to be masked. 9876 as it is. This is the 0th row. So 6439 as it is. So this is 1, not 6439 as it is. 6439 converted to 0000. And this is again 1. So this remains as it is, 7381. So check out what? 9876 should remain as it is, because the corresponding masking values, masking matrix says 1. So the 0th row remains as it is. 1th row, it is saying, masking matrix is saying 0. So 6439 converted to 0, 0, 0, 0. The next row as it is, because it is 1, masking matrix is showing 1. So 7381 as it is. So this is how this is what is the expectation from the program. So I will write this program, but one thing I want to point out before I continue with this program. In the previous program, remember one thing, while you masked, you did one thing. You were only checking the masking matrix corresponding value and you were converting it to 0. Another thing you could have done, you remember, multiplying a particular number by 1 keeps it as it is, and multiplying the corresponding number by 0 converts it to 0. So in the masking matrix, whichever position was 1, if you multiply by 1, it remains as it is. If you multiply it by 0, it converts to 0. So instead of checking it by if, you could have done one more thing. Please have a look at this. You could have done like this. Aij is equal to Aij is equal to Aij into mask ij. I think you understand what I mean to say. Why am I saying this? Because the array is 7654. Say one row of the array is 7654. The corresponding row of the masking matrix is 1001. So what are you doing? You are multiplying Aij, this is Aij, with mask ij. So 7 into 1, Aij, you are assigning it to Aij, remains as it is. 6, this is 6, multiplying it with 0. 6 into 0, that position converts to 0, you are copying it to Aij. So this way also the program could have been written. Isn't it so? However, I have just shown it as just an example, but however, you can write it in the previous way only. But still, let me run it once and see that whether it runs. Say 3 and 4 again. So 4, 9, 7, 5, 1, 7, 2, 3, 5, 3, 9, 8. So 4 values in the 0th row. 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 1. So 4, 9, 7, 6, 1, 7, 2, 3, 5, 3, 9, 8 original matrix. First row of masking matrix 1, 0, 1, 0. So 4, 9, 7, 0, 7, 5 converted to 4, 0, 7, 0. 1, 7, 2, 3, 1, 1, 0, 0 converted to 1, 7, 0, 0. 5, 3, 9, 8. So 0, 1, 1, 1 converted to 0, 3, 9, 8. So this way also the program could have been written. However, over here we go back to this new program now, where I want to mask a row as a whole. So 9876, 6439, 7381. How many rows? 3 rows. So how many elements in the masking matrix? Masking matrix is a 1D array this time. Only 3 elements, 101. So I will mask this matrix, this row as a whole, 9876 as it is, because it is showing 1, 0th row not to be masked. But 1th row, 0, to be masked. So 6439 converted to 0000. Next, Next element is 1. So 2th row needs to be masked. 7381 not to be masked, remains 7381. So let me continue with this. See, I will do only the changes that are required. Remember, mask is a 1D array now, because it only needs one dimension, only the rows. So I again ask to enter the number of rows and columns, %d, %d, scanf, ampersand m, ampersand n remains same. You enter the values, scan aij. Now enter the values of the masking matrix. I don't need to write row wise, but this 1 stroke 0 should be there. I wrongly deleted. So enter the values of the masking matrix 1 stroke 0. Now how many values are to be there in the masking matrix? Can you tell me? Equal to the number of rows. The number of values of the masking matrix should be equal to the number of rows, is not so? So I should tell enter the %d values of the masking matrix. What is that %d? Equal to the number of rows. What is the number of rows? M. M is the number of rows. So enter the %d values of the masking matrix 1 stroke 0 /n. So M, enter the %d values. This is M. M replacing this %d. Now I scan the values of the masking matrix. For I equal to 0, I less than m, I plus plus. Only I need one dimension. What is that? The m dimension, the value of m. So this can be deleted. Similarly, this for is also not needed, because I am only scanning once. How you scan a 1D array? You only scan it by like this. So you simply scan it. For I equal to 0, I less than m, I plus plus, scanf %d. Ampersand what? Is it mask ij? No, mask I. So what am I doing? I am scanning from mask 0 to mask m minus 1. Why? M is the number of rows. So how many elements in the masking matrix? Equal to the number of rows. Now the original matrix is, I print the original matrix, no problems with this. Now this checking. See how? For I equal to 0, I less than m, I plus plus. Now for each element of that row, I have to check. So for j equal to 0, j less than n, j plus plus, aij into what? See, let me write the example over here to make you so that you understand it easily. Say the element is 4, I write it over here, 4, 5, 6, 7, 2, 3, 9, 8, followed by 5, 7, 3, 8 or 2. Now the element masking matrix is given as 1, 0, 1. What do I need to do? When I am saying for I equal to 0, I am entering for this row. Now for j equal to 0, for I equal to 0, I am varying from j equal to 0 to j less than n. That is, for the 0th row, I am going through all the elements of the 0th row. Now all the elements of the 0th row needs to be multiplied with this 1. Is not it so? That is, aij needs to be multiplied with 1. With this 1, that is mask 0. Where is it? In I, mask I. I am for the 0th row. Remember, when you are entering with I equal to 0, you are in the 0th row. In the 0th row, all elements you need to multiply by this 0th number of this masking matrix. So you are multiplying all elements aij. For I equal to 0, you are multiplying all elements aij. With whom? With mask 0. Similarly, when I equal to 1, remember you are entering for the 1th row. That is, you are entering for this row. For j equal to 0, j less than n means that you are going through all the elements of the 1th row. What are you doing there? You are multiplying it with this element. What is that element? Equal to the row number. That is mask I. So this problem is solved over here. Now this masking has been done. Now I can print the matrix after masking. I have done exactly that. No other changes are required in this program. This program should work absolutely fine. Only thing is get rid of this, because this I explained to you only. Just the programming logic I tried to explain you over here. Anyway, let me run this program now. So Alt R, enter. Enter the number of rows and columns. 3 and 4 again. 4 values 2, 6, 8, 9. 1, 8, 7, 3. 2, 9, 7, 3. Now 3 values of the masking matrix. Remember, only 3 values. Why? Because there are 3 rows, 2, 6, 8, 9, one row, 1, 8, 7, 3 another row, 2, 9, 7, 3 another row. 3 values I need. So what are they? Maybe 0, 0 and 1. So what will you have? See, the original matrix is 2, 6, 8, 9, 1, 8, 7, 3, 2, 9, 7, 3. But after the masking is applied, because it is 0, 0, 1, 0th row vanished, 1th row vanished, only the 2th row 2973 remains as it is. I think you understand. You can do it easily for the column also. What I mean to say is, suppose you want now to mask a column. In this case, how many values will be there in the masking matrix? Because there are 4 columns, check out 4 columns. If you have to mask a particular column, that means you need 4 numbers, say 10, 10. 4 numbers you need because you want to, this means, this 1 means 967 as it is. This 0 means 843 converted to 0. This 1 means 738 remains as it is. This 0 means 691 converted to 0. So what should be the output after applying the masking matrix? Remember, 967 as it is. 843 converted to 0 because the corresponding position is 0. So here the masking matrix number of elements equal to the number of columns. Next number is 1. So 738 is the column, should remain as it is, 738. Next is 0. So 601 converted to 000. So if you have to do it for a column, then what to do? You again expect the values of the matrix row wise, scan it, enter the percent values of the masking matrix, not m this time, but n, because it is equal to the number of columns this time. So this for loop also not from 0 to less than m, it is 0 to less than n. Scan it, you scan the masking matrix. The original matrix is same. Now the masking begins. Now what will you do for the masking? Let us go through it column wise, that is for I equal to 0, I less than n. For j equal to 0, j less than m. What am I doing basically? For I equal to 0, I less than n, I am going through it column wise, I am checking one column, 0 to n, every time I am checking j01. So this time aij has to be converted to aji, aji is equal to aji into mask I. See what I mean to say. See with an example over here. 4, 5, 6, 7, 2, 9, 8, 3. Then 3, 6, 7, 4. Now the masking matrix will contain how many? 4 columns are there. So 1, 0, 1, 0. See what you are doing. For I equal to 0, I less than n, I plus plus. You enter with I equal to 0. Which numbers do you want to convert to 0? 4, 2, 3. That is A00, A10 and A20. So that is what you are doing. You are entering with I with 0. What you are saying? AJI. So I is 0. J is varying. So A10, 20, 30 less than M. So it will go only up to 3. 3 rows. So less than M means up to 2. So 0, 0, 1, 0, 2, 0. You are multiplying with whom? With mask 0. That is 1. Then I is 1. I is 1. It is going up to less than n. But J is 0, 1 and 2 less than m. So you are converting A01, A11, A21. A01, A11, A21. 01, 11, 21. You are multiplying with mask I. With whom you are multiplying? With mask I. This 0. So I think you understand this. Again, this program should run smoothly. I get rid of this part now. So let me run this program now. This program should work fine. So the masking matrix I have after masking the matrix, original matrix I have printed again. Let me run this program and see how it performs. Alt enter. Number of rows and columns 3 and 4. So 4 values 2, 9, 8, 7, 3, 5, 6, 2, 7, 6, 1, 9. Now 3 rows. Enter the 4 values of the masking matrix. Why 4 values? Because there are 4 columns. Is right so? 4 columns are there. So 2987 is the first row. So how many numbers are there in one row? 4 numbers. So how many columns are there? 4 columns are there. So let me run it. Let me enter it. 1 0 1 0. So see, 2987 3562 7619 original array. 1010. So see, 2307 remains as it is. 956 converted to 000. 861 as it is. 729 converted to 000. So you can understand this program works. I will again request you to go through this entire session once more. See the video again. Run the program yourself. Try to run it yourself. Try to write it yourself and run it yourself. Thank you so much. We will come back after a little bit of break. Thank you.